Number 31, solve the equation. We have log base x of 9 equals -2. Let's go ahead and rewrite our equation in exponential form. So we'll have x to the -2 equals 9. And we normally don't work with negative exponents. Sometimes we will, especially in these solving for logs or exponential equations. But let's go ahead and see what happens if we take this x to the -2 and move it downstairs so that our -2 becomes positive. Well, that will give us 1 over x squared equals 9. And let's just solve this like a regular equation like we would any other time. So we can multiply this whole thing by the common denominator, which in this case is going to be x squared. So we'll multiply by x squared on both sides. On the left, the x squareds cancel, so we're left with 1 equals 9x squared. And we can divide by 9 on both sides, and that'll give us, let's see, I'm going to actually go ahead and write the x squared on the left. So x squared, once the 9's cancel, equals 1 over 9. And we want x all by itself, so we'll take the square root of both sides. Don't forget, when you create your own square root or any radical with an even index, you have to remember plus and minus. So on the left we have x equals, and on the right we're going to have 1/3 and -1/3. All right, so, well, that's interesting. We got two answers. So are both correct? Is one correct? What's going on here? Well, if we were just solving for x in an algebraic equation, then both answers would be correct. But we have to go back and take a look at what we were originally solving for. We were solving for the base of a logarithm, And at this stage, right now in college algebra, we are not going to concern ourselves with negative bases. We can't have negative bases. So in that case, we're going to drop the -1/3, which means our only option, the only remaining answer, is going to be +1/3. And so in this case, x is 1/3.